Hello once again. Last time we set up the Ender Chicken on Aurelia and also did a little bit of Astral Sorcery to actually make it work, to finish off the entire automation. And the neutrons are now coming in at a pretty decent rate. I did also discover that I need to do the Naquadah line to do anything, basically. And so I've set up a little subnet here. Nothing is connected. It's just power and a controller. And the Naquadah line is going to go right here in the ore processing building. And it has been a while, I feel, but I can finally show you a flowchart again. So this right here is the NAC line in FTB interactions. It starts all the way on the left. You can see it starts with antimony trifluoride, which I actually need to make an initial batch of, and then it's looped forever. But yeah, so you start with antimony trifluoride and hydrofluoric acid in an LCR. This gets you fluoroantimonic acid and some hydrogen back. The fluoroantimonic acid is combined with Naquadah to get titanium trifluoride, impure enriched Naquadah solution, which is NQ+, and impure Naquadria solution, which is NQ*. The titanium trifluoride is cooked in an EBF with some hydrogen, and you get some hydrofluoric acid back. I didn't loop it back because it's not a perfect loop, but essentially each run of this is going to be a minus 2000 hydrofluoric acid and a plus 2000 hydrogen. Anyway, this also gets me hot titanium, which gets sent to the vacuum freezer. I decided not to show it on this flowchart because it's pretty obvious what you need to do. The two impure solutions, both of them get centrifuged, and I'm thinking of just doing both in the same centrifuge instead of making a centrifuge for each, just to reduce the amount of machine spam. But both get centrifuged, and the process for the rest is kind of analogous for the two different versions of Naquadah or Naquadria. So for enriched Naquadah, I get antimony trifluoride back, half of what went in, along with Naquadria solution, and some trinium sulfide. And I'm gonna need trinium in the near future to make trinium coils. For the Naquadria, we get indium phosphide, so this is finally a much better source of indium than the galena and sphalerite that I've been doing so far. And I get the rest of the antimony trifluoride back. I also get some Naquadria solution. This should be NQ*, but yeah, so the two solutions, Naquadria and enriched Naquadah, both get combined with sulfuric acid in a mixer to make the corresponding acidic solution. There's a partial loop here as well, which is going to be fun to handle. But both these acidic solutions are centrifuged. I think I'll do a separate centrifuge than the first one. And this gets us some enriched Naquadah sulfate or Naquadria sulfate, some fluorine back, and some waste, either enriched Naquadah waste or Naquadria waste. Both of these get distilled, probably going to use 1 DT, giving us either barium or gallium sulfide, sulfuric acid back, and both solutions. You get the enriched Naquadah and Naquadria solution. It's kind of cool. This reminds me of like electromagnetism in a weird way. It's like you can swap electric field and magnetic field and everything works kind of thing. Something like that. It's just weird. There's like a parity between these two sub lines, which is cool. Anyway, both of these are partially recycled into each other. So that's what these two recycling lines are, the dotted one and the other white one. The end product here, though, is the Naquadria sulfate and the enriched Naquadah sulfate. That's what I actually want out of this. Also the trinium. And those are the three main outputs. NAC line done. That was actually pretty easy. And I even managed to save on a centrifuge. I'm doing all the centrifuge recipes in one centrifuge, and it seems to be holding up pretty well. I don't know if there's really much to explain here. It's pretty short. So these two LCRs are for making the fluoroantimonic acid, which I handle outside of the AE2 network, so it's just an output hatch leading to an input hatch. And this is the first step that uses the Naquadah. I have a level emitter here so that I don't use all my Naquadah, because I do need Naquadah dust itself for other stuff. So this will only be on if I have more than 2000 Naquadah dust. The EBF and vacuum freezer are for the titanium. The centrifuge, there are 4 recipes in the centrifuge, the 2 impure solutions and the 2 acidic solutions. The mixer makes the acidic solution, and this DT distills the waste. And that's that. Now I think the centrifuge is a bottleneck, so maybe doing just one of them was not the right call, but honestly, it's fine. I can always multi-amp this. I can replace this with a 4 amp LUV energy hatch and then also upgrade the parallel control hatch to a higher tier, and then I should be good. The main bottlenecks, as far as I can tell, are this first LCR and the centrifuge. But yeah, hydrofluoric acid, sulfuric acid, hydrogen, and fluorine are all interfaced with the mainnet, along with all of the different dusts. So Naquadah in, and all of these different sulfates and sulfides and phosphide back into mainnet. I'm just going to pattern the use of these instead of making a dedicated electrolyzer or chem reactor or whatever. All the recipes are really fast, it doesn't really matter. So cool, that's Naquadah done. I have a little bit of trinium. 84 trinium is 42 trinium ingots. This does need Naquadah coils though, so I need to make that first. And then with the trinium, I can make superconducting coils. That's what this was for in the first place. And then I can do fusion. So that's kind of my goal for today. We'll see if I get there. First step, Naquadah coils. Coils have been swapped on both the EBFs and the alloy blast smelter. I've also upgraded everything here to LUV, and this has been a major problem because I don't make enough power. I only make like 4 amps of LUV, so that's like 1 EBF being powered because these are double hatched. So to help with that a little bit, I want to scale up my nitrodiesel production because the photonuclear fission has not been as good as I thought it would be, and nitrodiesel would be a lot better. And it's pretty obvious to me where the issues are. So first of all, these need to be upgraded from the large combustion engines to the extreme ones. And I've already crafted them, so that's good. I can swap these out at any point. Each one will make 1 amp of LUV. It needs liquid oxygen, which I'm now level maintaining, so that's also fine. The main problem though is that I am running out of nitrodiesel. In fact, I'm completely out right now, except for that steel drum over there. And the reason is fairly obvious. It is this distillation tower. This thing is super slow. It's still at HV, and I think the power profit here in this entire system is so high that I could overclock this reasonably and not have an issue. But to be a little bit more efficient, I've made a fractionating distillery controller. So I'm gonna have to do a little bit of rewiring here, but I can make a fractionating distillery. I can add a parallel control hatch. In fact, I could even make a master parallel control hatch, which is 4 times as good, 16 parallels, and I think I will. It's probably a good idea. It's a bit pricey right now for me to swap it out everywhere in my base, but eventually I probably will. I would also like to make the circuit assembler today. There's not much space, but I think next to the assembly line is probably fine, like over here. I can fit it in. I just need to actually make it, and it needs some LUV parts, which I have now. Once all that is done, I will move on to fusion. I've already made the scanned data stick for the controller, which was just indium tin, barium, titanium cuprate wire. That was pretty easy, but to actually make it, I need this plutonium-241, I need all of this other stuff. Yeah, it's a lot. But I can't do anything without power, so I'm gonna fix my power situation first. Well, that was actually a bit annoying to set up because it doesn't take a maintenance hatch. Did you know that? It doesn't take a maintenance hatch. I really, really wish all these multi-block controllers had tooltips on them. That would be so nice. Instead I just had to trial and error my way into finding out that it doesn't take a maintenance hatch, which is funny. But hey, this is going much better now. This is basically up all the time. It's out of power. Okay, well, that's easily solved, but there we go. This is going now, and now I'm gonna make my circuit assembler. This does, however, need crystal processor mainframes, which are, first of all, an assembly line recipe, and second of all, need a research station. Maybe I should just get fusion going first. Research station is a whole other rabbit hole because I need ZPM motors, so basically I need to be in ZPM. It's a whole, yeah, okay. All right, let's do fusion first. And by the way, for the plutonium-241, I found a much better way to get some. So originally I wanted to centrifuge uranium, but that's actually pretty bad. But there is a much better way. If you look for tiny piles of plutonium-241, you can get some by centrifuging oxidized ferric sand. This is basically the dirt of Aurelia. So it's very easy to get large quantities, and I can very easily get quite a bit of plutonium-239. Plutonium-239 I can centrifuge into plutonium-241. So this is actually faster than even the tiny piles directly. So this is how I'm going to get my 241 for fusion. Well, fusion has been set up now. I have everything in place, everything is hooked up, wired. AE2 is here as well. I need to connect the P2P, but that's fine. But I am not gaining any energy in the buffer. Why is that? Because these aren't running. Why is that? Because I'm out of nitrodiesel. Why is that? It's because I'm out of tetranitromethane. Not only that, earlier I had another issue because I ran out of liquid starlight. I have some now, but I've got almost nothing in storage, and I don't really want to spam more light wells. That's kind of silly. Instead, I want to make a collector crystal. This is very easy to make at this point. I'm going to put that over here, link it to all of these light wells, and that should make these operate much quicker. As for the TNM, the issue is pretty obvious if you look at the cell. The cell is full, the dimethylbenzene, which means something somewhere is backed up, but I'm just going to void overflow, so I'm going to add a trash can, filter it. We're chilling. Well, if it isn't the consequences of me being lazy. The structure's unformed. Remember that? Alright, I'm gonna fix that. Luckily, the structure overhaul was not that significant. It was just adding marble bricks over here, and then also this L shape on all four sides. And look at that. I didn't place that. That's just there. That's pretty cool. Now, I do have this attuned horologium celestial crystal. I think I'm just gonna use it. I don't see myself using it for anything else, really, so let's do it. It's almost nighttime. And that finishes Astral. I am curious how fast this is gonna be. Is it any faster? I don't know. I actually have no idea. I think it is. It's not as significant as I thought, though. Now let's test this thing out. Let's make some helium plasma. I'm actually also going to use this for power. I'm going to make a large plasma turbine, and this is going to make a lot of power profit. This is almost 82,000 EU for 1 liter of helium plasma being consumed. Not even consumed, converted back into helium. And to make 125 liters of helium plasma, it cost me 65,000 EU. Now, of course, the way fusion works is you need to have a certain amount of energy in the buffer as a starting point, and then all that energy gets consumed, and then the recipe begins. And while it's running, it consumes a much smaller amount of power. So there's an initial startup cost, that's a one-time cost for the recipe to start, and then we only use half an amp of IV to keep this going. Of course, we don't want to spend this 40 mega EU every single recipe, so I made the batch size really big. It's 128 buckets of helium plasma at a time. That is a little bit more than 1,000 recipe cycles, which is going to take 800 seconds. That's like a bit less than 15 minutes. I think that's okay. So let's request some and get started. Oh, right, tritium. Tritium is easy to get though. There's 2 methods. I do want to set up this method too, because it's kind of nice. This is distillation of liquid and/or air, but this costs quite a bit of energy. And for right now, I just want to make a little bit of helium plasma to sort out my power situation. Again, I thought I solved it like 3 times now, but I guess not. I'm just going to centrifuge a bunch of deuterium. Deuterium I have a lot of, because primal enriched eggs give you deuterium. Not a lot, which means I'm either going to have to centrifuge more hydrogen, which is not great, or, do the ender air stuff. But okay, let me get some tritium. Okay, let's go. Or not. Hello? All right. This was a bit of a weird situation. So I got my tritium and I tried this craft request, but for some reason it refused to push the inputs into the subnet over here. And I tried everything. I tried adding a dense energy cell. I tried adding a ME drive and nothing seemed to work. But now I finally got it to work. It's really weird, but the way it works is over here I have a storage bus facing a fluid packet decoder. And on the sending interface, I have it sending the fluid packet instead of sending actual fluid. So it sends these packet items that have the amount encoded onto them, and they go in as items, and so they're stored in the decoder. The decoder converts it into a fluid, and then the fluid is stored in the drive. Really weird. But now the inputs are here, and I've swapped out one of the input hatches. I haven't done the other, but I don't really need this hatch anymore. But I swapped out one of the hatches for ME stocking input hatch. And now I'm going to turn on auto pull. And we have fusion. Amazing. And helium plasma is coming in. And now this means we start the push for the creative storage key. And this beats the pack. This is a UV recipe, and it needs wetware mainframes. It also needs a chaotic core, needs 2 of them, which means chaos shards, which means infinity armor, which means infinity, which means neutronium. There's a lot to do. And of course, there is literally infinity and neutronium as well. But yeah, starting next episode, we start the push for, I was about to say gate. We start the push for the key. See you next time.